so let's see the question. The curve with equation y equal to e to the power of minus 2x ln x minus 1 has a stationary point when x equal to p. Show that p satisfies the equation x equal to that where exponent x denotes ex. Okay, so what we need to do is we differentiate it. So if I look at this equation, so it is clear that we need to use product rule as there are two x expressions multiplying each other. So which are u, v. So if you have u equal to e minus 2x, of course du dx, you differentiate the power minus 2, then followed by writing back the exponent. Then you have v equal to ln x minus 1. So when you do dv dx, we differentiate x minus 1, we get 1, we put at the numerator. So at the denominator, we put back x minus 1. So then we get our dy dx. dy dx is u, followed by dv dx, then plus v, followed by du dx. So du dx is minus 2e minus 2x. Okay, then the question said it has a stationary point when x equal to p. So we are going to substitute dy dx with 0 because of stationary point, and we are going to substitute x with p. So I'm going to do something like this. So at the meantime, I simplified it. So where I put the x minus 1, I replace with p minus 1, put at the bottom. And after that, minus 2 ln p minus 1, get the e, the e, I bring it down, e 2p. Okay, so I have this now, and now based on what they want us to show, so let's bring let's bring this whole thing to the other side first. Okay, you realize that there is no more ln over here, so we need to get rid of ln at the same time. Okay, so I'm going to bring this over there. Okay, so 2 ln p minus 1 e2p equal to, okay, so let's say I bring down this e also on the right hand side. So I will get 1 over e2p p minus 1. Okay, so I will get something like this. And after that, when I look at this, I realize what they do over there is they eliminate the EP on both sides. Okay, and then I get this one, 1 over p minus 1. Okay, then I continue here. I bring the 2 to the right, so I get ln p minus 1 equal to 1 over 2 p minus 1. Okay, then after that, I bring the ln over p minus 1. When you bring ln to the other side, it becomes exponent. So since the question is writing exp, so I just follow exp to represent the exponent. Exp 1 over 2 p minus 1. Then at the end, I bring the minus 1 over. I get p equal to 1 plus exponent 1 over 2 p minus 1. Then I say that P satisfies x equal to 1 plus exponent 1 over 2 x minus 1. Okay, so I managed to get the first part. Okay, so after that, this is actually the, yeah. Okay, so what we need to do is you have to decide whether your sign test is to perform on this one or this one or any other functions. So we need to decide on that. Okay, so how to decide? Actually, we have to think about it in this way. Let's say, I don't know how is the graph looks like. Okay, this graph, I just know that there is a stationary point at x equal to p. So let's say I draw out the graph and let you see. Okay, let's say I just simply draw it as I am not sure, and of course I'm not going to care about how the graph looks like. I just know that there is a stationary point at x equal to p. Okay, let's say I just put it in this way. Okay, so y equal to e minus 2x ln x minus 1. Okay, the stationary point is here, where x is equal to p. This is x, this is y. Okay, so first, can we substitute 2.2 and 2.6 2.2 and 2.6 into this curve? Okay, so let's imagine about that. If this is my stationary point, right? So 2.2 is before it, 2.6 is after it. So you won't get sign change over there because the situation is going to be something like this, you won't get sign change. You see, you substitute 2.2 inside, you get a positive value. You substitute 2.6 inside, you also get a positive value. There is no sign change if you are substituting it to the curve, to the y. You won't get sign change. Okay, so where we supposed to substitute, right? Supposed to be the function that creates sign change. Okay, so you see, when stationary points happens at x equal to p, right? So dy dx is equal to 0. Dy dx is equal to 0. So there should have sign change when you substitute to dy dx, because, okay, I put it in blue color. Dy dx represent gradient. So imagine that if I substitute 2.2 inside, the gradient at 2.2 maybe depends on graph, right? Depends on graph. Okay, so maybe it is dy dx, which is positive gradient. As you can see, the blue color line, that is the gradient of tangent. Okay, gradient of tangent. So at the meantime, if I substitute 2.6, so you can see the gradient of tangent that I draw over here. So you may get dy dx equal to negative. So sign test should be performed on dy dx. Then you will get a sign change. Okay, so where before stationary point, positive, or after stationary point, negative. Of course, if the stationary point is a minimum point, let's say, we don't know because we don't check it out. Okay, if the stationary point is a minimum, of course, dy dx is going to be negative before it. Dy dx is negative. Then after it, 2.6, dy dx should be positive. Dy dx is positive. Okay, so let's work it out then. Part 2, we substitute 2.2 and 2.6 into dy dx. So this is our dy dx, but this form is not simplified yet. So I'm going to use this form, this one is where I simplify already. Okay, oh never mind, I just use this. Okay, I put 2.6 into each of the x here. Okay, so dy dx, put 2.6 inside, e minus 2.6, then 1 over 2.2 okay, let's say I start with 2.2 first. 2.2, 2.2, 2.2 minus 1 plus ln 2.2 minus 1 followed by minus 2e minus 2 times 2.2. Okay, so let's check. We need to key in this whole thing. E minus 2x divided by okay, then we substitute 2.2. So we get 5.75 times 10 minus 3. So now we substitute dy dx equal, I substitute 2.6 into dy dx. So 2.6 minus 1 ln 2.6 minus 1 minus 2e minus 2.6. Okay, so I substitute there 2.6. Okay, I get negative 1.74 times 10 minus 3. Okay, so this is where from positive it becomes negative. So which belong to this situation? From positive it becomes negative. So it's a maximum point actually. Okay, so the sign test happened there. Okay, now we can say that sign changes, hence P is between 2.2 and 2.6. So let's continue with part 3. So part 3, they said use an iterative formula based on the equation in part 1 to determine P correct to 2 decimal places. Give the results of each iteration to 4 decimal places. Okay, so I do part 3 here. So they say you have to use this result, the result from part 1, which is this one. So you have to change this to iterative formula. The idea is you change left hand side to xn plus 1. For the right hand side, wherever you see x, you change it to xn. So xn minus 1. Okay, so like this. Now we start with the first x value. So what x value should we try? Normally we try the midpoint of the interval that has sign changes. So this one, 2.2, 2.6, the midpoint is going to be 2.4. So I will take the midpoint, 2.4, then I substitute into x1. So for the first one, let us show the working. 2.4. Okay, then we check with calculator. So you key in the whole formula into calculator. and then you press calculate, then you substitute in 2.4. Okay, 2.4. Okay, so we get 4 decimal places, 2.4292. Now x2 onwards, so I'm not going to substitute into the formula anymore. I just count it and write down the value straight away. So 2.4188. Okay, so actually what happened is I substitute 2.4292 into here. It's just that I don't write down, okay, because we have to save time also. You have to do it quickly. So that's why I just substitute 2.4292 over here, then I get 2.4188. Now I substitute 2.4188 into here again. Okay, since I key in everything in my calculator already, so I just use the calculator and get the next x value. 2.4225. Then I continue. I substitute 2.4225. Then I get 2.4212. So you may wondering, until when should we stop this? So you see the question again. They said determine p correct to 2 decimal places. So you can stop doing this when you found that when you round off the x value to 2 decimal and there is no difference, then it is time to stop. So for example, if you round off this one to 2 decimal, so it is going to be 2.42. If you round off this to 2 decimal, it is going to be 2.42. So then you can stop already. Even though if you look at the x2, it is already 2.42. So actually, if you do until x2, x3, you round off to 2 decimal is the same. It is time to stop. But just let's say just in case, if you feel like not so secure, you just try a few more to reconfirm. It is just fine because you are pressing calculator. Trying a few more does not take much time. Okay, so it's up to you if you want to try more. So for me, I will just stop like this. Then I just say x equal to 2.42, correct up to 2 decimal places.